So the latest video I posted was 10.3b class opener, but right now we're actually jumping into the actual notes on 10.3b, which is talking about geometric series, where you add up the sequence, the geometric sequence, where you add up the numbers to find the summation. Again, we already did this class opener on the previous video. If you want to watch that, go back and go ahead and watch that. And we've already covered the first part of 10.3 from the book. We should have memorized the a sub nth rule of a geometric sequence. And we went over those examples in the book. And now it's time for the actual notes. And just like all notes, we want to begin reviewing what we know. And of course, we have the a sub nth rule of arithmetic sequences right here. This is the machine that'll produce the arithmetic sequence. Of course, you need a common difference for that. And here's the geometric a sub nth rule. And of course, you need a common ratio for that. That's what makes an arithmetic is a common difference. What makes geometric is a common ratio. So these are the machines that'll produce the given list. All right. Now, in addition to the a sub nth rules of this arithmetic and geometric sequences, we also learned of summation formulas. For example, the arithmetic summation formula is S sub n, which means the summation of however many numbers you have on your list, will equal that many numbers on your list. Like if you have 17 numbers, you put a 17 right here, times parenthesis a sub 1, that's the first number on your list, plus a sub n, the last number on your list, all divided by 2, and multiplied by n, of course. So on today's section, we are covering the summation formula for a geometric sequence. Well, technically a series, because when you add them up, then you're talking about a series as opposed to a sequence. So what is the summation formula for a geometric series? There's actually two of them. There is these two right here. Now, I know you're thinking, what the heck? Why is there two different summation formulas? Well, the truth is, if you have a first term and a last term, then this one's easier to use. But if you only have a first term and a common ratio, of course you need a common ratio over here too, but if you only have the first term and a common ratio, then this one will work, right? So it depends. If they give you a first and last, go ahead and plug it in right there, get that common ratio, plug it in, and this is easier to use. If they only give you a sub 1 and no a sub n, no last term, then you would have to use this one. So it all depends on what they give you to determine which one's easiest to use. So our book gives us these two formulas, and the way they tell us, the key concept is if they provide an a sub 1 and an n, then you're going to use this formula right here. If they give you an a sub 1 and an a sub n, the first number on your list and the last number on your list, then you can use this one down here. So again, if they give you the first number on your list and how many numbers are on your list, then you could use this one. If they give you your first number and your last number, then you're going to use this one, okay? Let's see how that plays in this first example. I mean, it's a word problem, but it's as simple. They give you the first number being 5, common ratio is 5, and the n equals 8, all right? So since they did not give you a last number, they didn't give you your a sub nth term, so obviously you're going to be using a sub 1 and n, that's what they give you, you're going to be using this one. So when you plug it all in, there's the formula, because they didn't give you the last term, so you're using this formula. Plug it all in, work it all out, it gives you the summation of those 8 numbers on your list. Okay, they tell you that there's 8 numbers on the list. We also have this sigma notation down here. And sigma notation is just the summation of the numbers. And this is kind of like your machine that produces your list. So if you wanted your first term of the list, you would plug in the number 1, work it all out, and that would be, the output would be the first number on your list. Now keep in mind that summation problems with the summation notation, sigma notation, is really easy to do if you start with the number 1 and end with whatever number, right? If it's k equals 1, then you're going to plug in a 1 and work it all out, and it'll give you your first number. Then you'd plug in a 2, and then a 3, and then a 4, and then a 5, until you always get to the final number 10, and then you'll get that final number on your list. And then of course you would have to add it all up. And of course you could use the summation formula. However, let's begin by understanding that it's not from 1 to 10, okay? So it's from 3 to 10, okay? So how many numbers are on the list? That is the question. If we think about that, how many numbers are on the list? You know what? I just thought about this the other day. If I were to assign you questions 3 through 10, right? Questions 3 through 10. How many problems would you actually be doing for homework? Some people would say 7. Why? Because 10 take away 3 is 7, but that's incorrect. Why? Because you would actually count the number 3, right? 3, 4, 5, 6, 7, 8, 9, 10. So that's really 8 questions that you're doing, right? In other words, if you start at number 3, the only ones that you skipped were numbers 1 and 2. So I hope that kind of makes sense to you. The number of numbers on this list is 10 take away 3 plus 1. Remember that trick? 10 take away 3 plus 1. And again, it's kind of like if I said do questions 3 through 10. How many questions are you actually doing? You're actually doing 8, right? If you count the number 3, the number 4, the number 5, 6, 7, 8, 9, 10. If you add up all those numbers, that's an actual list of 8 numbers. You're only skipping the first 2. So again, the trick is this one, take away this one, plus 1. So there's really a total of 8 numbers on this list. Now, if you wanted your actual first number on the list, now remember, this is not a 1. So the first number on your list, according to this, is to plug in the number 3, and that'll be the first number on your list, all right? So when you plug in the number 3, that'll be 2 to the 3 minus 1. Do this exponent situation first. That'll really be 2 to the second. 2 to the second is 4, and 4 times 4 is 16. So the first number is 16. Some people get confused by labeling it a sub 1. I mean, if you want, just go ahead and put like first number. I don't get confused with a sub 1, but anyways. That 16 is going to go right here where the a sub 1 is at, okay? And it's also going to go right here where the a sub 1 is at. Now, do we know the common ratio? That's the question. Well, when you look at this and you think about the a sub nth rule for a geometric, let's go back to our notes, a sub nth rule for a geometric series, where is the common ratio at? The common ratio is this value right here, the base of the exponent. The base of the exponent is the common ratio. So if you have that memorized, you'll be able to look at this thing and say, oh, my base is 2 of that exponent, so my common ratio is 2. So you could clearly see that the common ratio is 2. So we know the a sub 1, which is 16, by plugging in the number 3 and working it all out. We got out 16, that's the first number on our list. We know the common ratio is 2. So now you're actually able to plug in the 2 for R right here. So it's really a 2. We know that there's a total of 8 numbers. Why 8 numbers? We said n was 8. Why? Because 10 take away 3 plus 1 is 8. So you really have 2 to the 8th power. We also know that a sub 1 is 16. So you put a sub 1 16 right there. A sub 1 16 right there. Then you work this math out with the calculator, right? 2 to the 8th, you do that first, get an answer, multiply it by 16. You're going to end up with 16 take away this huge number, and then you're going to end up divided by negative 1. So that huge negative number divided by a negative 1 gives you a positive 4,080. And of course, use a calculator. I would not do this by hand. Okay. So I think that's pretty straightforward, guys, the formulas that we're using. If we take a look at this example 5, could I have used the 1 instead? We use this one right here. Why? Because we were able to find a sub 1. We were able to look at the problem and identify R. But if I really wanted to, I could have done this one as well for that same problem. As a matter of fact, sorry about the moving screen, but here's the problem. I wrote it over again. And instead of using this one, I want to try to use this one. Let's see if we get that same answer. I think it was 4,080. So how could we find out our first number on the list? Well, we plug in this first value that they want us to plug in, which in this case is 3. Sometimes it's 1, sometimes it might be 7, sometimes 13. Who knows? Depends what number they want you to start plugging in and where to stop. So they want you to start by plugging in 3. That's going to be your a sub 1. Plug in 3. 3 take away 2 is 2. 2 squared is 4. 4 times 4 is 16. So we know that a sub 1 is 16. Okay. Now how about a sub n? How could I find out a sub n? Well, a sub n happens to be plugging in your last number. So you could plug in a 10. 10 take away 1 is 9. 2 to the 9th power, that is 512. So what we end up with is 4 times 512, right? And 4 times 512 is, that's 2048. Now keep in mind that this is the a sub nth. This is the last number on our list, 2048. Okay. Again, we found the first number by plugging in 3, working it out. I didn't really show my work, I just explained it. And then I took the last number, 10, plugged it in. 10 minus 1 is 9. 2 to the 9th is 512. 4 times 512 is 2048. That's my last number. So if I wanted to use this formula over here, I have my a sub 1, it's 16. I have my a sub n, that's 2048. And I could also find my r, knowing that the r is going to be the base of the exponent situation. So what is the base of the exponent situation? It's 2. So I know that my r is 2. So here's all the information that we need to plug it in to use this formula over here. So let's do this. A sub 1, 16 minus a sub n, the last number, 2048, times the common ratio r, which is 2, all divided by 1 minus r, 1 minus 2. So let's do the math here. We end up with 16 minus 2048 times 2 is 4096. It's still divided by that 1 minus 2, which is -1. So what's 16 take away 496? That answer would be negative 4080. So we have negative 4080 divided by -1. So that will give you a positive 4080. So the summation is positive 4080. I don't even know how many numbers are on the list, right? I don't know how many n terms are on the list, but I was able to find it using this formula. And that's the same answer as before, right? Here's the answer, positive 4080. So we use both formulas. It all depends on which one you want to use. And of course, if they don't give you the a sub nth term, the last term, then you probably just want to find the a sub 1 and use that first formula, okay? Now, all questions are not going to be straightforward like that, where they say find the summation of these numbers, right? Sometimes they'll give you certain information and ask for other specific information. Kind of like example 6 right here, straight from the book. It says, find a sub 1. They want the first number on your geometric series, for which the summation of all those numbers is 13,116, where there's 7 numbers on the actual list, and the common ratio is 3. So you got to, I mean, you have these notes over here, and you got to find out which one of these to use. Are you going to use this formula here, or are you going to use this formula over here? It all depends on what they give you, all right? So let's make these a little smaller. Let's just think about what they give us here. They give us S sub n. All right, so we could plug in right here or here, doesn't matter. They give us an n. Well, we could plug in an n up here. No, yeah, up here. And they give us an r, which is 3, which is right here and right there. So if I have my S sub n, my n, and my r, notice that they didn't give us an a sub n. So I'm not going to be using this one that has an a sub n, okay? I'm going to be plugging everything into here. So that's why they're using that one right there. Instead of me working this out, I'm just going to walk you through their work right here. So S sub n, they give you that answer, so they plug that right into S sub n, right? A sub 1 we don't know, so they leave it a sub 1. And notice that one also it says minus a sub 1, so we leave it minus a sub 1. Why? Because we don't know what a sub 1 is. That's what we're trying to find out, the first term on our list. We do know that the common ratio is 3 and that the n is 7. So plug in 3 for r, 7 for n, and you get 3 to the 7th, right? So when we plug in what they give us, we end up with this. And some people get confused right here. But what's happening here is we have an a sub 1 here minus an a sub 1 times something else. So we have a sub 1s on both. Check out what happens. You take the a sub 1 and a sub 1 and pull it out. You factor out that GCF of a sub 1. So what you have left is parentheses, and if you pull out the a sub 1, in other words, a sub 1 times what takes you back to an a sub 1? A 1 right there. A sub 1 times what takes you back to an a sub 1 times 3 to the 7th? Would be a 3 to the 7th. So I hope we understand that we have a GCF here up on top. We have an a sub 1 and an a sub 1. That's what we pull out. And what would be left? A 1 and a 3 to the 7th with the minus sign in between them. Again, we factored out an a sub 1. Anyhow, now let's do this math. 3 to the 7th, and then 1 minus that 3 to the 7th will give you negative 2,186. And of course, that a to the 1 times it, they just put it at the end. It's negative 2,186 times a to the 1. And it's divided by 1 take away 3, which is 2. Now, right here, you could actually divide this right here. Okay, you could actually divide negative 2,186 divided by negative 2. That'll give you a positive 1,093. The a sub 1 is still there, so you have 1,093 times a sub 1. Last step would be to divide by 1,093, divide by 1,093. That huge number divided by 1,093 is 12. So your first number on your list is 12. I know, that is kind of confusing. Let's move on to the actual practice or the assignment for today. Page 677, numbers 11 through 15. So let me ask you this. If I assign you these questions, how many are you actually doing? Are you really only doing 4 questions, or are you doing 5? Well, you'd be doing 15 take away 11 plus 1. 15 take away 11 is 4. 4 plus 1 is 5. So you're actually doing 5 questions. Why is that? Because you're including number 11, right? Anyway, we're doing 11 through 15, and I'll do a couple of them, you'll do the rest. I'll do number 12, okay? Number 12 says find the sum of each geometric series. You could do number 11. If you don't want to go through the PDF, just hit pause, copy down number 11 in your notebook. I am going to do number 12 right now. Okay, 12 is right here. And the question is, which formula will I use? You could actually look at this and find your a sub 1 term by plugging in the number 1 right in here and working it out. 1, all right, so let me actually write this down, guys. I want to write a sub 1, plug in 1 right in here. 1 take away 1 is 0. Anything to the 0 power equals 1, and 1 times 4 equals 4. So there's my a sub 1 term. If I want, I could use the first formula as is right now, because I know my a sub 1 is 4. My a sub 1 is 4. My common ratio will be the base of whatever power situation we have right here, which in this case the r would be 1/2. So the r is the fraction 1/2. So I could use this one. It's ready to go. But if you don't like factoring out that a sub 1 term, then you might as well just plug in the 8 to find your a sub nth number, which is the last number, okay? So if you want, you could plug in the 8 to find the last number, the a sub nth number, okay? So let's do that. Let's plug in an 8 right here. 8 take away 1 is 7. So we have 1/2 to the 7th power. I might as well show my work here. 4 times 1/2 to the 8 minus 1 power. That'll be 4 times 1/2 to the 7th power. And if you do 1/2 to the 7th power, we'll end up with 4 times 1 over 128. And of course, the 4 and the 128 could cancel. So the 4 cancels with the 128. You'll have a 32 left over on the bottom. So it's 1 over 32. This is your a sub nth rule, 1 over 32. Your a sub nth number, I'm sorry. So you have your first number, which is 4. You have your last number, which is 1 over 32. You have your common ratio, which is 1/2. We could actually use this second one now. So it's up to you. If you wanted to, you didn't have to find the last number, but you're going to have to factor out an a sub 1 term to simplify, to solve your problem. Or you could plug in the last number, get your a sub nth term, and then use this s sub n formula. So let's use that s sub n formula right here. S sub 8, no, not 8. How many numbers are there? there's actually 8 take away 1 plus 1. Obviously, there's 8 numbers, right? You start with 1 all the way to 8. There's going to be 8 numbers on your list. 8 take away 1 plus 1. That's really 8. So let me start my formula over here. S sub 8 equals, my a sub 1 term is my first number 4 minus, and actually let me do this with the correct color coordination here. 4 minus a sub n, and we said a sub n is the fraction 1 over 32, and then times the common ratio r, which is 1/2. And it's all divided by the fraction 1 over r, which is 1 minus the common ratio r, which is 1/2. Okay, so let's do this. Let's begin by multiplying 132 times 1/2. So up on the numerator, we will end up with 4 minus 1 over 64. And it will be divided by 1 minus 1/2. So what's 1 take away half? It'll simply be half. So this is what we have so far. Let's continue to simplify. I'm running out of space. Let me make space over here. So 4 take away 1 over 64, that's going to be 3 and 63 over 64 divided by 1/2. Okay, and we might as well change this to an improper fraction to help us out a little. Let's go 64 times 3 plus 63. We will end up with 255 over 64. And then we have a divided by half, which is the same thing as multiplying by the reciprocal, right? Dividing by a fraction is the same thing as multiplying by the reciprocal, which would be 2 over 1. So then you would be able to cancel out the 2 with the 64, leaving you a 32 on the bottom, okay? So 255 times 1 is 255. 32 times 1 is 32. And here is your answer. So this is your answer. The summation of the 8 numbers on this geometric series is 255 divided by 32, which in the answer sheet, they actually changed that to a decimal. So if you actually divided 255 divided by 32, that would be about 7.9687. And that's exactly what they wrote as an answer in the back of our textbook, 7.9687. Let's go back to the book and see. I mean, if I did 12, which was pretty complicated because of the fractions, I'm pretty sure you guys will be able to do number 11. We also need 13, 14, and 15. So I'll do one of them, and you guys could do the other 2. So I will do number 13. On number 13, they don't give us the a sub n term. They don't give us the last number on the list. So I cannot use this one, right? They do give us an s sub n. I could use s sub n on this one. I could have done it over here also. They give us the r. I could use a r there and r there. And they give us an n being 6. You could put a 6 up there or a 6 over here. But see, that 6 would imply a sub 6, and you don't know that last number on your list. So it's better to go with this one. I mean, you have to go with this one. It just depends on what information they give you. So let's do number 13 right here. We end up with s sub n. Right, if we're looking at the formula, S sub n is really 85 and 5/16. 85 and 5/16 equals the fraction a sub 1 up here on top, a sub 1 up here on top, but there is no a sub 1, so we don't know. We're just going to keep it a sub 1, minus a sub 1. We don't know. We're going to keep it a sub 1, times the common ratio r to the n power, times 4 to the 6th power. So I'm going to put times 4 to the 6th power. And on the bottom we have 1 minus r. 1 minus that common ratio, which they give us, is 4. So the trick is right here. You have something minus something else, and there's the multiple of a sub 1 on both. So I'm going to pull out that a sub 1 from both of these terms. I'm going to pull out the a sub 1. So if I pull out that a sub 1, what would be left on the inside? What binomial would be in here? Well, think about it. A sub 1 times what gets us back to that a sub 1? That'll be a sub 1 times 1 will get us back up there. And then a sub 1 times what will get us back to a minus a sub 1 times 4 to the 6th. That'll simply be a minus 4 to the 6th. So let's do that. Let's put minus 4 to the 6th. That's what we call factoring out the common multiple a sub 1, and it will be over -3. So we need to work this out right here, guys. Let's begin with order of operations, parentheses first. Inside of the parentheses, you have exponents and subtraction. So you're going to do exponents first. 4 to the 6th power is 4,096. So what we really have here is a sub 1 times 1 minus 4,096. That'll be 4,095. If you go 1 take away 4,096, it'll be negative 4,095. Of course, all divided by -3. And it's still equal to this 85 and 5/16. Now, we need to simplify this, obviously, before solving for a sub 1. So when you look at a number divided by a number, if it's possible, because there's multiplication, you could actually cancel this out. You could actually divide this through. So let's actually take a calculator and do 4,095 divided by 3. That's 1,365. So let me rewrite this thing. There we go. And again, all I did was divide this negative number by this negative number. It gave me that positive number. So I still have the a sub 1 times this, equaling that. And from here, we want to get a sub 1 by itself. Now, this might confuse some of us. So if you want, change it to an improper fraction, multiply 16 by 85, and then add 5 to it. And you would get 1,365 divided by 16. Okay, so this fraction is exactly the same, except this is a mixed number, this is an improper fraction. 16 times 85 is 1,360, plus 5 is 1,365 over that 16 equals the a sub 1 times the 1,365. Okay, so now let's get rid of that 1,365 by dividing by 1,365. And what you do to one side, you must do to the other, right? Right here, it cancels out. Over here, let's divide by 1,365. Let me actually rewrite this. I'm going to write the 1,365 over 16, and I'm going to divide by that number, 1,365. Now, as you could see, when you flip this to change it to a multiplication, you'll get 1 over 1,365, and of course, they cancel out. Your final answer is 1 over 16. So what did we solve for right here? We solved for a sub 1. A sub 1 equals 1 over 16. A sub 1 equals 1 over 16. So on number 13, that took a lot of work. I hope you guys were able to follow along. On number 13, the answer is a sub 1 equals 1 over 16. This helps. Let's take a look at the answers here. And again, I already did number 11 for you. No, I did 12 for you. You could do 11. It's done the same way. I also did number 13. I used the first formula, the one that did not have the a sub n, because they didn't provide me with a sub n. That's a different story down here on 15. When you guys do 15, use the summation formula that has a sub n, because they give you a sub n equals 4. Good luck.